In this skill, we're going to be figuring out the entropy change for different processes. Entropy is a measure of disorder. Disorder means chaos or randomness. So anything that increases the chaos or randomness in a system increases the entropy. There are lots of different things that could affect entropy. One factor that affects entropy is the state of matter that we have. So a solid has the particles ordered and patterned next to each other, whereas a gas has the particles moving around randomly. So a solid has the lowest entropy, a gas has the highest entropy, and a liquid is somewhere in the middle. So if we have a reaction where we're changing from a solid to a liquid or a liquid to a gas, the entropy is going to be increasing. Whereas if we have a reaction where we're going from a gas to a liquid or a liquid to a solid, the entropy is going to be decreasing. Similarly, moles of gas is a factor that's important. Say we have a reaction that starts with very few moles of gas and goes to having many moles of gas. The more gas you have, the more entropy and the more randomness you have. So lower entropy would be fewer moles of gas, and a higher entropy would be more moles of gas. Another factor to do with gases would be the volume of gas. If a gas is in a bigger volume, the particles have more space to move around in, and so they could be in more possible locations at a given time. So we've got more randomness. So a smaller gas volume will have lower entropy, and a larger gas volume will have higher entropy. Another state we can think about is whether something is dissolved or not in solutions. If we have a solid, it's very ordered, then we dissolve it in a solution and the particles all break apart and move around randomly in the solution. So a solid is going to be low entropy and a solution is going to be higher entropy. It's worth noting that there are a few exceptions to this. There are some solids that when they dissolve in water, the entropy actually decreases. However, this is rare. Most of the time when a solid dissolves in water, the entropy increases. Finally, we can think about temperature. Temperature is a measure of the kinetic energy of the particles. If we have a higher temperature, our particles are moving faster, and therefore we have more disorder. So a low temperature would mean lower entropy, and a high temperature would mean higher entropy. So in order to predict the entropy change in a reaction, we need to look for which of these factors is changing and figure out how that's going to affect our entropy. In this question, a scientist wants to predict the sign of the entropy change for the following reaction in a rigid container at constant temperature. Here's the reaction. We've got CH3OH gas forming CO gas and 2H2 gas. So let's think about what's changing in this process. First, let's think about state. We've got a gas on our reactants and gases on our products. So there's no change in the state. What about the moles of gas? Well, we're starting with 1 mole of gas, CH3OH, on the left. And on the right, we've got 1 mole of CO and 2H2 gas. So we've got 1 mole in the reactants and 3 moles in the products. So we do have a change in our number of moles of gas. What about the volume of gas? Well, we're told it's a rigid container, so it's going to be staying at constant volume. So there's going to be no change in the volume of the gas. What about solutions? We only have gases here. We don't have anything dissolved in solution. So we've got no change there. And lastly, for the temperature, we're told the reaction takes place at constant temperature. So there's going to be no change there. So in this reaction, the only thing that's changing is the moles of gas. And we're going from fewer moles of gas to more moles of gas. So based on this, that must mean we're going from lower entropy to higher entropy. In other words, we're increasing our entropy. So let's go ahead and fill out these questions now. What changes during this process? We already decided the number of moles of gas increases. So here's the answer. The reaction results in an increase in the number of moles of gas. How does this change affect the disorder of the system? Well, we know having more moles of gas means we have more entropy, so more disorder. So the disorder of the system increases. What is the effect on the entropy of the system? The entropy of the system increases. So what will the sign in the entropy change of reaction, which has the symbol delta S naught, be for this process? So if it's positive, we have an increase in entropy. If it's negative, we have a decrease in entropy. So in this case, we know we have an increase in entropy, so the entropy change is going to have a positive sign showing it's increased. So in these questions again, all you need to do is have a look at the reaction taking place and figure out which of these factors is changing. If we're going from lower entropy to higher entropy, then our disorder and entropy are increasing and the entropy change of reaction will have a positive sign. If we're going from higher entropy to lower entropy, then our entropy is decreasing, our disorder is decreasing, and our entropy change of reaction will have a negative sign.